Okay, let us continue. There's a very interesting question. So, you said, Sir, baka naman kulang lang yung pantukod. Okay? So, what we are talking about is not the column itself, but the shoring or the pulse work. Okay? So, as you can see, there are plenty of shoring and pulse work already. Okay? And that means, actually, if you want to pass through underneath this construction, you have difficulty of passing through because of the plenty of the number of support of the pulse work. Okay? The issue here is actually not the number of support, but the proper installation. Okay? The proper, mostly the support should be vertical. Okay? Most of the support are slanting in diagonal. Okay? Many supports are diagonally placed. It is better for the support to be vertical. Okay? And there are only some points wherein we need what? Diagonal support. Okay? However, even in the diagonal support, as you can see here in this left side, the diagonal support is actually in reverse direction, in the opposite direction. It is much better to do this diagonal support in reverse direction or in the opposite direction, like this one. This is the correct diagonal support here. So, meaning to say, all in all, the number of shoring or the pulse work support is not the issue here. Okay, there are too many of them already, but the strength of the support have to be designed. So pulse work, shoring, formworks are designed. As we already talked about this in at least 2 videos. We already have 2 videos about formworks, part 1 and part 2. For formworks and pulse work. And what is the what design standard for pulse work and formworks? The design standard is ACI 347. As we already mentioned in those 2 videos. Right? One of the video, which is the part 2, I just updated this morning. Okay? I just gave you the link for the part 2. Okay? Okay? So this morning. So meaning to say, there is no proper design on the pulse work. Okay? They just put up so many support, and they expect them to be able to carry the actual pouring of concrete. They did not bother about designing the pulse work itself. However, in our course, we do not go to the design of pulse work, but we just discuss about the principle. We already discussed about the principle. We are not going into the details of how to design it. Okay. We already gave you the principle to let you be aware that there is such a thing that we need to design. Okay? That is important. So any other question? Are there any other questions?
Sir, question lang po, sir.
Okay.
Sir, tanong lang po, ba't di po nila nilagyan ng beam doon po sa gitna ng 2 column na may sukat na 18 meters?
You mean from this column up to that column?
Dito po sa gitna. Doon po sa may sukat na 18 meters, sir.
This is 18 from
po.
the this in the front, this one in the front here. Okay,
Sir.
so you are talking in the front facade, no? Facade of the building. So this front. So actually, as you can see, the protruding formworks, okay, and reinforcement. This is the footprint. This is the footprint of the beam. There is a beam. This is a protruding formworks. There is a beam, but the difference is the beam is being poured by concrete cement at the same time that the slab is being poured by concrete cement. So they will get the same curing time. They will get the same concrete strength. Meaning to say, the beam and the slab is a single unit. Okay? They are not separate from one another because they are being poured by cement. Pouring meaning in our local language, ano ang Tagalog sa pouring? Buhos. So, sa Tagalog, buhos. Yung pagbuhos ng semento, ng concrete, actually is magkasabay na. Okay? Sabay yung buhos sa beam at saka sa slab. Sabay yung pagtigas nila. So that's why I'm talking about. So that is how we describe it in our local dialect. So meaning to say, this beam existed. Existence of beam are already there, but they are being poured at the same time by concrete together with slab. And because of that, what is the type of connection? What is the type of beam application is that? That is what we call fixed beam. That is what we call fixed beam. That is how fixed beam looks like in real life. Okay? So, you already know about fixed beam as a theory, as a principle, as you discuss it in your prerequisite subject, theory of structure. This is how it looks like in real life. Okay? Fixed beam meaning slab, beam, and column are what? Poured at the same time, and therefore they are homogeneous. They are homogeneous. Okay? They are not separated from one another. So that's the answer to your question. We have a beam. We have a beam. Every so I think we have a beam here. I don't know. Okay. So I see the beam protrusion here. There is a beam. There is a beam footprint here. There is a beam footprint there. There is a beam footprint there. So there are beam because there are different types of frames. There are types of frames that we don't need beam. Beam is not necessary actually. Okay, beam is not necessary. If you do not have beam, therefore you have to design your frame differently. Right? So I don't know if there is some time dedicated or devoted for that discussion. I don't know. But in the previous curriculum, previous courses, I always discuss the different types of frames in concrete structure. So there are about 6 different types of frames. There are frames that is so common. The most common type of frame is column, beam, and slab. That is the common type of frame. But those are not necessary. Beams are not necessary if you have another type of design. Okay? Okay, any other question? Question?
Ask ko lang po.
Ah.
If any chance po ba, ano po siya, parang dahil po sa mga materials na ginamit, hindi po ganun kaano yung quality.
Okay, so of course, it's possible that, for example, the quality of reinforcement is not great. It is a low quality. The same is true with the cement. The cement itself. The same is true with the sand. Even sand and gravel, the quality must be okay because we need the sand and gravel to be less smooth, no? We need their surfaces to be rough. We need sand and gravel surfaces to be rough so that it creates greater bonding. It creates greater hold bond with each other. If the surfaces of gravel and sands are what? Smooth, okay? Sa ating local dialect, makintab na makintab, makinis, no? Dudulas yan, no? Hindi yan kakapit, no? Okay? So, that's why the quality of these materials, even if these are gravel, that's why it is important for the gravel not to be the river stone. River stones are to be avoided for use in construction as gravel. That is to be avoided because river stones are smooth in its surface, no? Therefore, it is very difficult to hold. There is there is very limited friction, no? So we need friction for sand and gravel to hold itself. So even those simple material, if you don't select it properly, their quality is not the right quality, and therefore this happens. Of course, that is a good observation. Not only that, also the quality of formworks and the quality of false work. So this materials quality, we can actually find out after it fell, after the failure. We can send civil engineers to evaluate what is the cause of failure, and we can do that. We can take some of the pieces and study in the laboratory. Take some of the materials out of that. Okay, take an ample amount of material for us to be able to study those material in the laboratory. The formworks, the false work, the steel reinforcement, the sand, gravel, the cement itself. Okay, the type of cement. There are 5 types of cement. Actually, there are 5 types of cement. And if you have an error or mistake in selecting the proper type of cement, there is a problem. However, in our country, only engineers of high-rise building, medium-rise building will bother about that. Residential construction will not bother about that. They will just buy anything from the hardware, whichever is available. Okay? They will not even care about what is the type of cement. Okay? Okay? So there are 5 types of cement. So proper use of material or low quality material is one of the causes of this. Okay? One of the causes. So therefore, it is still a responsibility of those engineers. Okay? Still a responsibility. If you sign that you are the engineer in charge of construction, that is your responsibility. Okay? So any other question? Okay. So somebody from this video just stated that no one were injured in this incident. It's a good thing. It's a good news to know. No one is injured. I can't believe no one will be injured here. No one will be injured. So most probably the statement that they floated that no one is injured, maybe it means there are small scratches, and what they just dirt their clothes. Okay, there are plenty of dirt and costly failure, but injury from the point of view of human health and safety, maybe only minor scratches. Minor scratches. So that's a good thing to know. Okay. Okay. So after, as you can see, after the structure fell down, so we can now start to laugh because there is nobody injured. There's nobody injured. There are 7 persons walking after the failed structure. So therefore, all the 7 persons who fell down are really not injured because they can still walk. There are 7 persons walking. Okay, so 1, 2, 3, 4, 5, 6, 7. So there are 7 persons walking, going out of the ruins of the failure. So, okay. So that's all for this. I will give you time to take a break, and then we will again meet 11 o'clock. Okay. Okay. Thank you.
Thank you, sir.
Sige po, sir.
Thank you
Thank you
po,
po.
sir.
Yes, sir.
Thank you, sir.